Okay, so this is one of our typical workstations in the lab, and everything is close to hand. We've got the function generator on the top. We have our power supply, which can go up to about 30 volts. It's all DC, and we have our oscilloscope. Now, we do have the soldering irons and the holder and the wick remover in a really expensive, fancy piece of wood to do your soldering on. But those are normally kept clear. We usually have them stored away until it's time we need to do some soldering. This is the printed circuit board that comes with your parts kit that you'll be using to do the soldering. So let's set that aside for a second. Now, when you get your kit, it comes in a little bag like this, and inside the bag it has a color chart, which is handy. I'm going to help you to memorize the resistor color code bands because you're not going to have this in your wallet. And I know you'll take a picture with your cell phone, but it will be buried behind a bazillion other pictures, and then when you need it, you don't have it. So that's where we use the gray matter and we memorize it. It's not that difficult. There's different ways of doing it, but we're going to go through that in the course. You're going to get a small parts bag, and in that parts bag you'll find what looks like little bugs. These are integrated circuit chips. Now, it comes on this foam, and some previous students have decided to remove the chips and then throw this away. Don't do that. Save the foam, because these particular chips are susceptible to static electricity, and just being around, you can actually take a perfectly good chip and make it not function good. So make sure you keep the plastic. Now I recommend that you get yourself a little tiny plastic box like this. I got this for $1.50 at the Dollarama store plus tax. Now I have a few, and they are free to use as long as I get them back at the end of the semester. I have not had a lot of luck that way. Somehow the end of the semester comes and I say bring them back, and I don't get them back. So I'm not a charity. I just out of my pocket, but I don't mind helping you out as long as you give them back to me. You'll get a brand new breadboard, which when you open it up, there's another piece inside. It's hard to see. There's a little piece of metal that's supposed to be stuck on the back. You just peel it back and stick it. Some of the parts, let's go over some of these, just so you know what we're going to be dealing with. So in your kit, one of the things you're going to do, it has a little inventory list. And once you get the kit, it's kind of like mini Christmas, but you're to do an inventory, because I have had it happen where there's been one resistor or another that's not there, and it's called for in the lab. You go, oh sir, I don't have that resistor, and then I have to go and see if I have an extra one. I do try to keep a few spares because sometimes experiments go not according to plan, and we let the magic smoke out. And when you let the magic smoke out, it doesn't work anymore. So, for example, we've got this particular resistor. We're going to go over what the different sizes are, because these are all quite large. And then you have another resistor that's like a little baby cousin. So that's part of what we're going to talk about. We're going to talk about the different sizing, what they mean, how to apply them. You're going to get an assortment of different color LEDs. More than 4, and we're going to be using those. We're going to actually make some circuits where we're going to make some logic decisions. So we'll turn on a switch, turn on another switch. If those both are true, then it will turn on a third light to say that both the other two switches are true, that sort of thing. And that'll be done after we've gone through other stuff using these. There's also a couple of switches, so you can do that. Then we have these. They look like resistors, but they're got a little single stripe on them. These are diodes. We'll be using those. And you have a couple of different types of transistors, little tiny things these are, and those are the evolution. When we're working through this, I always like to try to have a beginning, a middle, and an end, like a simple story. And this whole course is kind of a flow through. So you've already had basic electrical theory. You understand what resistance is, voltage, and amps. So we're going to start off with a quick review. First couple labs are kind of a quick review to go over some of that theory, to confirm Ohm's law, confirm Kirchhoff's law, and examine what happens and why it is they put resistors in a particular format on a given board. What's it there for? What's the purpose of that? Then what we're going to do is we're going to look at how a diode works, what's its construct, and why do we need a diode? I mean, they don't look very useful here, but from that we're going to figure out how they make a transistor based on some diodes, and then after we've done that, you put a couple of transistors together and you get the possibility of creating a logic gate, something that can make a decision based on inputs. And if you're taking the PLC course, then different inputs turn on and execute certain outputs. This is the electronic version of the same thing. So we will construct a simple circuit with the transistors and understand how they work. And that leads to the integrated circuit chips. So it all kind of flows through. We build in one lab, we'll build on the next, and then we'll throw the theory in as well so that you understand what's going on. And overall, by the time this course is finished, you should really begin to appreciate how little voltage and current can make a huge impact. I mean, if you think about your cell phone or your laptop, it's got billions and billions of these, and these, and these, and it doesn't take a lot. I mean, we're charging it with a USB cable that's 5 volts. That's all there is. It's not 120, it's not 240. You draw more current to turn the lights on. So, understanding the principles of it, some people will take it up as a hobby. I worked with a gentleman, my former employee. He actually really got excited by working with this. So much so, he actually went retro, because one of these diodes used to be a vacuum tube, and he is rebuilding antique radios. He just absolutely adores it. He uses one of these, he uses one of these, he uses one of these. It's just old school. So, when you get your kit bag, make sure that all the parts are in there that it says it's supposed to be in there. And what we're going to do, one of the first labs we're going to do in the class is we're going to use those, we're going to put them on our breadboard, and we're going to get you to use your meter. We're going to get you to use the meter to check to make sure the resistance, and record it, and we'll start working and getting familiar with the different screens on your meter. Keep in mind that just like I showed that old Simpson, well, it's actually a new Simpson, but the Simpson analog meter, every meter is slightly different. They're never exactly the same. So we're going to go through the different types of meters, what to look for, why one's maybe better than another for certain applications, and what the dial does and what the different positions are, because you can be looking at something and be misinterpreting the information simply because you have your meter in the wrong position. So we're going to go over that. So we will see you in class.